Question 2 is about what happens when electrons strike atoms. So this means that it's an energy levels question, and it's what happens inside things like a fluorescent tube. Now normally in those questions we concentrate on the energy of the electrons that are inside the atom. This question takes a slightly different approach because it gives us information about the energy of the electrons that are doing the bombarding, so the ones that are coming from outside being fired through the tube and are hitting the atoms. But the physics will still be the same. So the first part of the question, got a 6-mark written answer required. So it says, explain what is meant by the ground state of an atom and describe the process that is taking place when these atoms emit photons. Because the atoms are hit by electrons, and as a result of that, photons are emitted. So whenever you get a question like this where you've got space to write, there's usually a number of points that you're supposed to mention several of. Very rarely will anyone give a totally perfect answer that mentions absolutely everything, but provided you mention a reasonable number of points, you're going to get a good mark. So these are the points that the examiners have specified. The question's about energy levels. So if you mention that an atom has got energy levels, they're going to give you a mark for that. A lot of people clearly understood about energy levels, but they never actually mentioned it. You might think it's too obvious. If you're talking about atoms, you probably take it for granted that there are energy levels. But if you don't actually say that to the examiner, he can't give you a mark for it. Now the question did say what is meant by the ground state, and of course the ground state is the lowest energy level, or the lowest energy state that an electron or an atom can occupy. And they're not worried whether you're talking about the state being the state of the electron or the state of the atom. Now what's going on in this situation? Electrons that are coming from outside, being accelerated in the tube probably, they're colliding with the electrons that are orbiting the atom. When the electrons from outside collide with the electrons that are in the atom, they give energy to the electrons in the atom, and that energy can cause the electrons in the atom to move to a higher energy level. When the electrons in the atom are in a higher energy level, of course they're not going to be stable there, so they're going to return to a lower energy level. When they do return, they've got to lose energy. How do they lose the energy? Well, they lose the energy by emitting a photon of radiation. And so the question did ask you to explain, why do you get photons of various frequencies emitted? So you mentioned that the energy of the photon depends on the difference between the energy levels which the electron is falling through. And of course it doesn't necessarily go straight to the ground state in one stage, it might go through several stages to get there. In terms of how the actual marks are awarded, this grid sort of shows it's a combination of how much good physics is in there and how well it's expressed. It can be penalised, of course, because even if you've got some good physics in, if you also make a silly mistake that sort of shows that you've got a real misunderstanding, you're going to be penalised for that. Now, a couple of people mentioned ionisation. Well, it is of course possible to ionise atoms in this way, to have an electron that comes on, hits the electron in the atom and gives it enough energy for it to leave the atom completely. In this particular situation, the fact that you're getting photons emitted, that does tell you that the electrons are going to higher energy levels and coming back down, so that the atom isn't being ionised. There's at least one person who referred to metals, which sort of rather got me worried, because in this question it doesn't say anything about it being metals. When this sort of thing's going on, we're usually dealing with individual atoms on their own. We know that it's important we're talking about metals if we're dealing with a photoelectric effect, and this question is nothing to do with that. Now part B, this is where the question is a little bit unusual, in that instead of dealing with the energy of the electrons that are part of the atom, it gives you information about the energy of the electron that was shot at the atom, the one that was in the tube that was accelerated. And it tells you in the case of the first electron, it had an energy of 5.5 electron volts before it hit the atom, and it still had an energy of 5.5 electron volts after it had hit the atom. So that electron didn't lose any energy. So it didn't give any energy to the atom. So it didn't cause one of the electrons in the atom to move to a higher energy level. The second electron, on the other hand, had 9 electron volts before collision, only 1 electron volt of energy after collision. So the second electron has lost energy, so it's given energy to the atom, so it must have caused one of the electrons inside the atom to move to a higher energy level. we're asked to explain why that happens. And the obvious explanation as to why that happens is that the first electron volt that's got 5.5 electron volts of energy, that energy isn't enough to promote one of the electrons in the atom to the next energy level. And since the electron can't be promoted part way, it's got to be either all or nothing. If 5.5 electron volts isn't enough to make an electron in the atom move to the next energy level, then the electron doesn't move to the next energy level. It doesn't accept the energy, and the electron that came in from outside rebounds and it keeps its energy because the atom can't accept it. In the second case, 9 electron volts is more than enough to cause an electron to move up to the next level. So the electron does move up to the next level. It takes the energy it needs to do that, which is 8 electron volts, which means that the electron that came in from outside is left with the remainder, which is 1 electron volt. So I've waffled quite a lot there. So what would you write here? You'd say the first electron does not have enough energy to promote an electron in the atom to the next energy level. The second electron does have enough energy to give to the electron in the atom to promote it to the next level. Part 2b, convert 9 electron volts into joules. Well, most people got this right, but a few people got mixed up, because a few people were dividing instead of multiplying. If you know that 1 electron volt is 1.6 times 10 to the minus 19 joules, which you should know, then 9 of them has got to be 9 times 1.6 times 10 to the minus 19 joules. So 9 electron volts, 1.44 times 10 to the minus 18 joules. For the last part, calculate the maximum frequency of the photon emitted when the 9 electron volt electron collides with an atom. Now, a lot of people made the same mistake with this. Everybody got the right general idea. Everybody knew that the energy of a photon is given by E equals hf, and that we're trying to find the frequency of this radiation, so we're finding frequency equals E divided by h. And the examiner's report said that a lot of people made this mistake, and reading the question, I totally sympathise with anybody making the mistake. And the reason I sympathise is because it says that this electron is colliding with an atom, and you might think that could be any atom. So you might think this 9 electron volt electron, well, look, they've made another mistake there. That should be capital V, shouldn't it? If this particular electron happened to collide with a sort of atom where there were 2 energy levels that were 9 electron volts apart, then it would be possible for it to promote an electron through 9 electron volts. But what the examiner had in mind is that when it says an atom, it's talking about an atom of this element that the whole question's about. And this question is about an element where the atoms don't have energy levels that are 9 electron volts apart. They have energy levels which are 8 electron volts apart. So in this question, when we're saying how much energy does the photon have, it doesn't have 9 electron volts, it only has 8 electron volts. So 8 times 1.6 times 10 to the minus 19 divided by Planck's constant, (1.9 times 10 to the 15 hertz.